Any other questions? Okay, sorry. Number 12. So you can turn in these even worksheets when we turn in our odd worksheets at the end of class today, or won't be at the end of class. We should be done before the end of class. We did finish early in first period. All right, so the square root of 12 minus 7 square root of 25. It's a subtraction, so we can't add or subtract unless the number under the square root is the same, right, Fatima? So right now they're not the same, but if they can be simplified, they may be simplified to the same square root. So that's what we're looking at. So what can you factor the square root of 12 to maybe simplify it? Square root of 4 and the square root of 3x, right. So the square root of 4 times the square root of 3 minus, what about the factor of 75 would be perfect square? 5 and 25. 3 and 25, yes. So we're going to put the perfect square, let's stick our number on the outside there, minus 7 times the square root of 25 times the square root of 3. And so hopefully we're getting pretty quick at the square root of 4 is 2, the square root of 25 is 5. So we're at 2 square root of 3 minus, remember the numbers on the outside get multiplied, so minus 35 square root 3. So now we have square roots that have the same number under the radicand or under the square root. Rather, they are called the radicand. They're under the radical. We can also call the square root symbol. So subtract the coefficients. 2 minus 35 equals negative 33 square root 3. Make sense, Fatima? 16? What did you get for 16? Sorry? Okay, so how do you think like that in our notes? The 23 minus 4 all squared, which means that the square root of 3 minus 4 times the square root of 3 minus 4. Right? And so then we do it just like we did number 18. Alright, so try it. You can try it after we do the odd ones. I'm happy to go over classes with you that you tried it, but if you didn't try it on your paper, I don't really want to work with it. Right? We will do some that are just like it. But from this point, it's just like, similar. You have to do the devolution like you did here. We should all know at this point, though, anytime something is squared, it just means you're multiplying that thing by itself. So that should never stop us. Any other questions? Right. So hold on to the even if you did. You can turn it in with the odd here in a few minutes. We are going to do this assignment together. And then you can turn it in for full credit. So what is 3 squared root of 7 plus 5 squared root of 7? So you've got 3 problems here that don't require work. After that, they all require work. 1, 3, 5, no work. What's the answer to number 1? 3 squared root of 7 plus 5 squared root of 7. Say it again? 8 squared root of 7, right? So if the number under the square root is the same, you just add the coefficients. Everyone should be writing what I'm writing. Same way with number 3, whether it's addition or subtraction. I do. You can take a second for one. You can put it on my desk. Okay. So Or when you divide them, Lee, will you take your AirPod out for me? Vivian, will you take your headphones off for me? I can't hear you. Okay. And number 4. What is 4 squared root 13 plus 4 squared root 13, Brooklyn? No. No. Oh, no. Look up here. 3 squared root 7 plus 5 squared root 7. All we did was add the 3 and 5. It's 8 squared root 7. Did you write that down? Look at number 3. Because the number under the square root is the same, 11 squared root 5 minus 4 squared root 5, all we did is take the 11 minus 4, and that's 7, and write the square root 5, right? So for number 5, I asked you, what is 4 square root 13 plus 4 square root 13? 8 what? 8 square root 13. Yes, I knew you could do it. Right, so no work on medicine. Everything has to do at least a little work. So for adding and subtracting, remember, all of these have to have the same number under the square root. That's why we could do these real quickly, because they already did. These two, you might be go, oh, well, they're not the same, so we're not going to subtract them. But one of them is not simplified, so we don't really know, unless you simplify those terms, whether or not it can be added or subtracted. Not only that, even if we couldn't add or subtract these at the end, we would still simplify this term because it's going to simplify, right? So simplifying does mean adding or subtracting, but it also means if we can't add or subtract them, we simplify each term as much as possible. So 4 squared root 7, that's not going to change. Minus, is there a perfect square factor of 63, students? Sorry? What you just said, what you said. Yeah. Which one's perfect square, 7 or 9? 9. Okay, we're going to write it that way. So the square root of 9 times the square root of 7. So when we're looking to find the perfect square, we're looking for the perfect square of the number under the square root, right? But then when we write it, we've got to write it out of the square root. So now, this is already simplified again, but that square root of 9 is what? 3. So now what we have is 4 square root 7 minus 3 square root 7. So what's the answer to that, Brooklyn? 4 square root 7 minus 3 square root 7. Okay, so 4 minus 3 is what? 4 minus 3 is 2? Sorry? 1, right? So 1 square root 7, but we don't write the 1. Just like if we have 1x, we don't write the x. I'm sorry, we don't write the 1, right? If the coefficient is 1, we don't write that. All right. Let's go up to number 9. Can I simplify 6 square root of 8 and 2 square root of 50? Says yeah. All right, so 6 square root of 8. What's the perfect square factor that we can unfactor square root of 8 into, Kendall? If you get stumped, don't listen to factors. We don't really need the 1 though, because the 1 never is going to do us any good. So let's start with 2 times 4. Well, the 1 might help us if we, because the number itself is a perfect square, but the number itself is a perfect square. Hopefully we'll recognize it right away. Are either of these perfect squares, Kendall? Which one? 4. So we can use that, right? So we're going to rewrite this as 6 times the square root of 4 times the square root of 2. Minus 2. What can we factor the square root of 50 into? 25 and 2, as Terry said. So we're going to rewrite the square root of 50 as the square root of perfect square factor of 25 times the square root of 2. And so now, simplify what we can before we multiply. So square root of 4 is 2. Square root of 25 is 5. My board doesn't work. 5. So we multiply the outside number. 6 times 2 is 12 square root of 2. Minus 2 times 5 is 10 square root of 2. What's 12 square root of 2 minus 10 square root of 2, Brooklyn? What's 12 square root of 2 minus 10 square root of 2? 2 what? 2 square root what? Yes. Any questions? Number 9? Number 9, we said number 11. Maybe number 11 over here. Let me save some room here. All right. Can we add 5 squared 18 plus 4 squared 32, Maya? No. How can we rewrite 5 squared 18 so we can simplify something? Any idea in now? So we're looking at the factors of 18. Give me some factors of 18 top of your head. 2n. 2 times 1 is 18. You know, 2, take 18 divided by 2. 9. So 9 times 2 is 9 a perfect square? Yes. So that's what we're going to do. So it's going to be 5 here times the square root of 9 times the square root of 2 plus 4. What's a perfect square factor of 32, Jeremiah? So you get stumped, remember, start at 2. 2 times what is 32? 16, right? Are 2 or 16 perfect squares? Remember what a perfect square is? So which one of these is a perfect square, Jeremiah? Yes. So 4 times the square root of 16 times the square root of 2. Simplify what we can here. Square root of 9 is 3. Square root of 16 is 4. Multiply what's on the outside. That's 15 square root of 2. Plus multiply what's on the outside. 16 square root of 2. So what is 15 square root of 2 plus 16 square root of 2, Emma? Yeah, 31 square root of 2. So that is how we add square roots if they have the same square root or if they have different square roots. And once again, you might simplify them and not actually be able to add them or subtract them. These, when we simplify, we could always add or subtract the coefficient. But sometimes you're going to simplify it, it's going to be 4 squared root of 7 minus 3 squared root of 5, and that's okay. Okay? That would be the simplified answer. Alright, number 13. All we're doing is simplifying here. Just means getting rid of parentheses. So we're going to multiply, and then we're going to simplify any radicals, combining like terms so we can. So there's only one term on the outside, so we just use that number on the outside and multiply by everything on the inside. So the square root of 3 times the square root of 12. What's the square root of 3 times the square root of 12? Diane? Sorry? It is. The square root of 12 times, square root of 3 times the square root of 12 is the square root of 36. And Diane went ahead and simplified that to 6, right? I'm gonna do an extra step in there. The Zion's right. That's going to simplify to 6. And then the square root of 3 times 4. What's the square root of 3 times 4? Can you see what's the square root of 3 times 4? That's it. Good job. The easy ones sometimes seem like the hard ones. Plus 4 square root of 3. We're just going to write the 4 on the, put it in the right order, right? And then, like Diane said, the square root of 36 is 6. So this expression, in its simplified form, is 6 plus 4 square root of 3. Or you could say 4 square root of 3 plus 6. Either way works. Okay? Any questions? Same thing for number 15. What's the square root of 7 times the square root of 7? We should know this. I'm not going to write that. I'm not going to take an extra step here. Right, but if we have a square root of 7 times the square root of 7, do we have to go to the square root of 49? This is 7, right? If we're multiplying by the exact same square root, you just write the number under that radical, under that square root. So it's 7, and now it's square root of 7 times negative 2. Anthony, what's the square root of 7 times negative 2? Very good. So it's going to be minus 2 square root 7. And that's it. That can't be combined, simplified even more. Any questions? Remind you while I'm thinking about it, today I'm going to review worksheets. Remember, the bonus questions are required on your homework. They're optional on your test. They don't count against you. On your homework, you lose points if you don't do the bonus problem. Well, it reminded me that this is one similar to our bonus problem on the review worksheet. The only difference between 17 and 15 is we have to distribute two different numbers, right? Because both of these have to be multiplied by both of these. So that's all we're going to do. We're going to do the square root of 2 square root of 3 times 6 square root of 5. Number times number, square root times square root. If you remember that, that will help you. Number times square root times square root. So 2 times 6 and square root of 3 times the square root of 5. So same thing here, 2 square root of 3 times the second term over here. So 2 square root of 3 times negative 4 square root of 3. Number times number, square root times square root. What's the square root of 3 times the square root of 3? 3. We're going to do times 3 there. Now we've got to multiply the second term by everything in those parentheses. The square root of 5 times 6 square root of 5. What is square root of 5 times 6 square root of 5? So those both positive because I put plus. What is this number here if you don't see it? 1. So number times number is 6. Square root times square root is what? Square root of 5 times square root of 5 is what? 5. And now square root of 5 times the last one times negative 4 square root of 3. Positive times the negative, and then it's going to be minus. So what is square root of 5 times 4 square root of 3? Akira? Yes. Negative 4 square root 16. So now we combine everything that we need to combine. That's going to be minus 24. That's going to be plus 30. So negative 24 plus 30 is 6. So we're taking care of those. And then 12 square root 15 minus 4 square root 15 is what, Brooklyn? Okay, you're supposed to be writing what I'm writing, honey. I'm going to let you extend this in for full credit, and you don't even have your pencil in your hand. Well, you're writing some of it, okay, but I need you to write all of it, all right? What's 12 square root 15 minus 4 square root 15? 8 what? 12 square root 15 minus 4 square root 15. So 12 minus 4 is 8. What goes under here? 15, that's right. Remember, when you add and subtract them, that number under the square root can never change. When you multiply or divide them, that number under the square root symbol can change. All right. The bottom ones down here have radicals in the denominators. We cannot leave radicals, no square roots in the denominator, and we learned a strategy to easily get it out of there. And that is to multiply by the conjugate. So we're looking at the conjugate of the denominator here. So the square root of 11 minus the square root of 7. If anybody remember how to find the conjugate of that, what is the conjugate of the square root of 11 minus the square root of 7? Beautiful. It's exactly the same thing. Square root of 11, square root of 7, but if this is a subtraction, so we make this a plus. If that were a plus, we make that a subtraction. Remember, if we multiply the bottom, we're going to multiply the top by the exact same thing. So, when we multiply the top, it's going to be 12 times square root of 11 plus square root of 7. And remember, there's a shortcut to multiply the bottom. Normally, we would do double distribution, but we don't have to do that. It's just, because it's a difference in squares, we multiply the first term. What's the square root of 11 times the square root of 11? 11. It's always minus. What's the, now we multiply the last two. What's square root of 7 minus square root of 7? What's square root of 7 minus square root of 7? 7. So now we're going to distribute and simplify this, and now we'll get a final answer. Well, actually, I can make this the final fraction. So this would be 12 square root. Actually, let's do this right here. Let's go ahead and simplify this in here. That make sense to everyone? All right. Can we cancel 12 and 4 here? Can you simplify 12 and 4? 4 comes out of 4 one time, and it comes out of 12 3 times. So we have 3 times the square root of 11 plus the square root of 7. Now we just distribute. 3 square root of 11 plus 3 square root of 7 is your final answer. The coefficients are the same. That doesn't matter. Square roots are not the same. The number under the square root symbol, the radicand, is not the same, so we can't add them. That's your final answer. Challenge 21. Same kind of dealio. I need to multiply by its conjugate. What's the conjugate of the denominator here? Fatima, what's the conjugate of 37 minus square root of 3? I just want to know what is the conjugate. So here, look over here. This is the expression square root of 11 minus square root of 7. The conjugate is just the square root of 11 plus the square root of 11. So what's the conjugate of square root of 7 minus square root of 3? Yes, that's exactly right. Square root of 7 plus the square root of 3. And if you multiply it by the bottom, we're going to multiply it by the top. All right. So we're going to simplify the top. 32 times square root of 7 plus square root of 3. And then we're going to use our shortcut, our strategy, to multiply the bottom. Square root of 7 times square root of 7. What's square root of 7 times square root of 7, Xavier? What's the square root of 7 times square root of 7? No? The square root of 7 divided by the square root of 7 will be 1, though. Yeah. Square root of 7 times square root of 7. What's the square root of 7 times square root of 7, Ulrich? Yep. So if you multiply the square root by itself, it's always just the number underneath. The square root 7 times square root 7 is 7. Square root 3 times square root 3 is 3. Square root 5 times square root 5 is 5. Make sense? Okay. So square root 7 times square root 7 is 7. It's always minus. What's square root 3 times square root 3 figure? Yes. And 7 minus 3 is, everybody? 4. So now, the 4 can be simplified with the 32. 4 is a factor of 32. So 4 comes out of 4 one time, and it'll come out of 32 8 times. So that's going to simplify to 8 times square root 7, 8 square root 7, plus 8 times square root 3, 8 square root 3. Right? That was just distributed property thing. Any questions? Last one. As long as you've written everything down that I've written down, then you can turn this in for full credit for an assignment group today. What is the conjugate? What is the conjugate for the denominator for 23? That's what we need to know. Can you see what's the conjugate here? Beautiful. Square root 5 minus square root 2. If that goes in the bottom, it has to go in the top. Do you guys know why if it's in the bottom, it has to go in the top? What is 8 divided by 8? What is million divided by a million? What is xy divided by xy? What is square root of 5 minus 2, minus square root of 2 divided by square root of 5 minus square root of 2? 1. So if we are, basically, we're just multiplying by this by 1. What happens when you multiply 3 times 1? What do you get? When you multiply 8 times 1, what do you get? You don't change the value of it, right? So we're multiplying by a different form of 1 that lets us get that out of there. So we're going to go ahead and leave this in parentheses for now on the numerator. 30 times the square root of 5 minus the square root of 2 over, now we're going to use our shortcut. The square root of 5 times square root of 5, Xavier. The square root of 5 times square root of 5. Good. Always minus. What's square root of 2 times square root of 2, Brandon? 2. And 5 minus 2 is 3. Can we simplify 30 and 3? We can. 3 comes out of 3 one time, and 30 will come out of, 3 will come out of 30 10 times. So our answer is 10 square root 5 minus 10 square root 2. I just went in and distributed that. How are you feeling about 10 dash 3, okay? Okay. You can pass your 10-3 and 10-4 if you did it, and I'll take a basket for you. And we're going to go ahead and work on our review worksheet. We still have about 15 minutes, and I will work on it with you. Hurry up. Leave your phone. Beautiful. Pass your worksheets up to the front if you're ready to turn them in. Thank you. I can't hear you. You get extra credit on, can you write that on there? Your notes will be obvious because they get turned in online. Your find yours in there and extra credit. Okay. All right, so we're going to look through your review worksheet and work any problems you want to work together in class. We'll do the same thing tomorrow for the view worksheet. You will see, as all year long has been, number 1 is going to look like number 1 on the test on both review worksheets. Is another going to be the same? Probably not. That has happened that they were, right? Number 2 is going to look like number 2 on the test. Number 3 is going to look like number 3 on the test. Your process is going to be the same. So make sure you know how to do all of them. We sure will do number 4. Good question. So number 4. Number 4 has numbers and variables under the square root symbol. I would recommend highly that we just go ahead and separate them at the beginning and simplify them separately. So we're going to rewrite this as the square root of 125 times the square root of x to the 7th times the square root of y to the 3rd times the square root of x to the 8th. So everybody start doing that. Now we'll take each square root at a time and rewrite it as factors with a perfect square factor. What is a perfect square factor of 125? Do you know already? Okay. Well, we know one will come out of there, but 125 is not a perfect square, so we're going to keep going. It ends in a 5. So if it ends in a 5, it's a multiple of 5, right? So let's try 5. 5 times what equals 125? Are either of those perfect squares, Alice? 5 and 25? What makes it a perfect square? 25, right? So remember, what makes it a perfect square is 25 has a pair of factors that are the same number, 5 times 5. 4 is a perfect square because it's got a pair of factors that are the same, 2 times 2. All right, so we're going to rewrite this, and I'll put my square root, perfect square factor first. Square root of 25 times the square root of 5. And we can go ahead and simplify that now if we want. What's the square root of 25? You just said it. What's the square root of 25? 5. Now, the variables are a little bit harder for kids for some reason, but remember, when you multiply the same variable, you're just adding the exponent, right? So if we have x to the 5th, really that's just us multiplying 5x's, right? So a perfect square factor, so x to the 1st is not a perfect square factor, but x squared is, right? And there's an x squared in there. But we can use x squared, give me a little bit extra work. We have 4 x's. Is x to the 4th a perfect square? It is, right? So we can rewrite this as x to the 4th times x to the 1st, and now we get a perfect square. So let's do that. Perfect square factor. And we're going to do the same thing with this y. I don't write yours in the answer over here. I just don't really have any extra room. So square root of y cubed. We're going to rewrite the y cubed as the biggest perfect square factor. What's the biggest perfect square factor of y cubed? What do you think, can you say? What's the biggest perfect square factor of y cubed? And remember, it takes out this y squared and gives y, right? So we've got y cubed, we've got a y squared in there, right? So yeah, it's y squared, square root of y squared times the square root of y. And last but not least, the square root of d to the 8th. What's the biggest perfect square factor of d to the 8th? X to the 4th, but yes. I'm sorry, d to the 4th. This is the square root of d to the 4th times the square root of d to the 4th. You didn't sign up. simplify these already. What's the square root of x to the fourth? What, Keyshawn? X squared, beautiful. And we can't simplify the square root of x. What's the square root of y squared, Matt? Square root of y squared. What do you multiply by what to get y squared? Yeah. Y to the first power is not a perfect square. Z to the fourth times z to the fourth. What is z to the fourth times z to the fourth? I'm sorry. Square root of z to the fourth times square root of z to the fourth. What's the square root of 3 times the square root of 3? 3, right? So what's the square root of z to the fourth times the square root of z to the fourth? Z to the fourth, right? So we could do the square root of 2 times the square root of 2, but that's going to be z to the fourth. So what do we have left for number 4? 5. What else is not under the radical? So 5 we got. X squared, not under the radical. Y, not under the radical. And z to the fourth, not under the radical. Under the radical, also moves to the square root. 5, x, and y, right? Make sense? Okay. Anybody else see one that you want to do together? This is your homework we're doing. 15, 14. Yep. Okay. Spoiler alert, this is one of the ones I told you we're going to simplify it. Because you're thinking, oh, well, one of the reasons we're going to simplify it is it says to simplify, but then we're going to think there's a chance that we're going to be able to add or subtract things that we're not going to be able to do. That's okay. But we know that 54 has a perfect square factor of what? 9. 9 is the perfect square factor. So we're going to rewrite 3 square root of 54 as 3 square root of 9 times square root of 6. What's square root of 9? 3. Minus 5 times square root of 7. What's the perfect square factor of square root of 7? Times 27, rather. 9 again, right? So 5 times square root of 9 times the square root of 3. Square root of 9 is 3. Plus 7 times, what's the perfect square factor of 45? Brooklyn, your little hand should be moving along with mine, honey. Square root of 9 times square root of 5. And square root of 9 is 30. So now to simplify, we need to go back and multiply all the coefficients. So 3 times 3 is 9. 9 square root of 6. Minus 5 times 3 is 15. 15 square root of 3. Plus 7 times 3 here. 21 square root of 5. Now we check here. 6, 3, 5. None of those can be combined, so our final answer is 9 square root of 6 minus 15 square root of 3 plus 2 square root of 5. Good? Start. Oh, my bad. 21, yeah. I see 21 here. I should have did you ask another one, Keisha? Sorry? No? Anybody else have a question that you want me to work with you guys? Anybody see one that you think you'd like us to work together? No? Fatima? 14 over 1. Would everybody agree with that? We can rewrite this as the square root of 14 over 1 minus the square root of 2 over the square root of 7. I'm going to do this completely different than I did in first period, I think. I think the easiest thing to do is just to go ahead, let's go ahead and get this radical out of the denominator. Let's go ahead and multiply this whole thing by square root of 7 over square root of 7. It's going to kind of kill two stones here. It's going to get us, I don't know if it's going to make it any easier or not, but we're going to see. I don't know. Hold on. I don't really like that way. So you have big numbers to work with. Scratch that. What will be pencil? Let's just go ahead and try to simplify this. Square root of 2 over square root of 7. To get that radical out of the bottom, we're going to multiply by square root of 7 over square root of 7. So now we're going to have the square root of 14 minus the square root of 14 over 7. Does that make sense, Keishan? And so now, the problem we have is, the denominator here is 1, the denominator here is 7. All we have to do is multiply both of these by 7. So now we have 7 square root of 14 over 7 minus square root of 14 over 7. And we have 7 minus 1 square root of 14 all over 7. Does that make sense? Listen, what you doing? You're not supposed to have your phone out.